Hello, my name is Kate Calvin. I am an earth scientist at the Pacific Northwest National Lab. This video provides an overview of what's new in the latest release version of the Global Change Analysis Model, or GCAM model. This new version, version 5.4, was released in July of 2021. This video assumes you have a background knowledge in GCAM and only provides information on changes made since the last release about a year ago. There are other videos providing overview of GCAM and how to run it. Here is a summary of the major changes affecting the standard GCAM scenarios. I will cover most of these changes in more detail in this presentation. First, we've improved representations of several aspects of GCAM in version 5.4, including technology costs, emissions, trade, and food demand. Next, we've added new features, including water markets in GCAM USA and energy for water. I will not cover water markets in GCAM USA in this video, as there is another video focused on GCAM USA. We have also made some infrastructure updates, minor updates, and bug fixes, which I will cover here. Lastly, we have reorganized the GCAM documentation. We recognize that different users have different needs for documentation, and we are trying to make it easier to find what you're looking for. First, we've improved technology costs for electric generating technologies and transportation technologies. For electric generating technologies, we have updated to use data from the National Renewable Energy Laboratory's Annual Technology Baseline, or ATB. We use these assumptions for electric power capital costs and operating and maintenance costs. ATB provides information on costs through 2050. Those costs are extrapolated to 2100 for inclusion in GCAM. The figure on the right is showing capital costs for different electricity generating technologies in GCAM version 5.3 in red, in ATB in blue, and in version 5.4 in green. As you can see, the costs have shifted for several technologies between versions 5.3 and 5.4. Next, we have updated cost, intensities, and load factors for transportation technologies to use information from the National Renewable Energy Laboratory's Electrification Futures Study. We have improved the representation of emissions in GCAM version 5.4. We are now using data from the Community Emissions Data System, or CEDS, for historical emissions. We have also updated the final historical year for emissions to 2015 to align with the rest of the model. We have updated the marginal abatement cost curves for greenhouse gases to use estimates from a more recent EPA report published in 2019. We have also added the option to scale historical methane and nitrous oxide emissions to match EPA inventories instead of CEDS. This is an option that is not enabled by default. We have improved the representation of trade. In particular, we have updated trade for fossil fuels and forestry to create regional markets with global trade, similar to the representation of trade in agricultural commodities within GCAM. In this representation, we track gross trade, differentiating between imports and domestic consumption and between exports and domestic production. The figure on the right is a simple schematic showing a two-region example of this trade structure. Here, as you can see at the top, demand can be met by either domestic commodities or imported commodities, and at the bottom shows that production can either go towards domestic consumption or towards the trade sector. We have also updated the logit exponents governing crop trade to reflect more recent literature. This slide provides a summary of the main trade approaches in different versions of GCAM. This is an active area of development within GCAM, and how we represent different commodities has changed between versions 5.2, 5.3, and 5.4. This slide shows a summary of those changes. We have also improved the representation of food demand. We now group commodities into staples and non-staples. Both groups respond to changes in income and price, and these changes are linked. So an increase in the price of non-staples will reduce the demand for non-staples and can also increase the demand for staples. There's more information on this food demand model in the two papers listed on this slide. We are now explicitly tracking the energy used for water abstraction, treatment, distribution, wastewater treatment, and desalination. Historically, this energy for water accounts for about 4% of global electricity demand from industry and commercial sectors. Future demand in GCAM is driven by the scale of future water demand. More information is provided in the paper listed on this slide. The figure on the right shows global energy for water in the GCAM reference scenario, shown in green, and in the GCAM 2.6 watts per meter squared scenario, shown in orange. These results are from the latest release version of GCAM, version 5.4. We've made a number of infrastructure updates. First, we've made updates to the solver and changed some libraries. Specifically, we are now using the singular value decomposition algorithm from the Eigen library to improve solver behavior. Next, we are using multiple CPU cores to run GCAM via the Intel TBB library. This is now enabled by default and can significantly reduce runtime. We have updated to a newer version of the BaseX library, and we've made other updates to the solver algorithm. Next, we have updated GCAM data, the system used to generate inputs for GCAM, to use Drake. We've added this new driver Drake, which keeps track of what needs to be rerun when you make a change to the data system. This change should significantly reduce data system runtime when you are continually making small changes to the data system or its inputs. Finally, we've removed unused code. There were a number of files in the GCAM repository that were no longer used, and we've removed these to reduce confusion. Lastly, we've made a number of minor updates and bug fixes, including adjustments to the representation of dried distillers grains and feed cakes to improve solution performance. We've added a profit shutdown decider for refineries in GCAM USA, meaning that these refineries can be shut down if costs exceed revenues. We've corrected some minor errors introduced in the previous release version. And finally, we've made some changes to the GCAM data system to work with the latest version of some of the packages it was dependent on, in particular Tidyverse, which has had some updates since the last release. I'm now going to show some results comparing GCAM version 5.4 to GCAM version 5.3. I will not show all outputs, and instead will focus on a small sample. This first figure shows global electricity generation in exajoules per year. The left column shows results from version 5.4. The middle column shows results from version 5.3. The right column shows a difference plot showing the difference between version 5.4 and 5.3. In this plot, positive values indicate larger values in version 5.4 than in version 5.3. Please note that the scale on this right column is different than the scale of the y-axis on the left two columns. The top row in this figure are results from the reference scenario. The bottom row is results from the 2.6 watts per meter squared scenario. As you can see here, changes made between version 5.3 and 5.4, in particular changes to electricity power generating costs, have resulted in a change in electricity generation that is significant. In particular, we see a large increase in solar and wind deployment in version 5.4 compared to version 5.3. This figure shows global land allocation in the same layout as the previous figure. Here, the differences between version 5.4 and 5.3 are rather small. This is because most of the updates between version 5.3 and 5.4 have focused on other sectors. This plot shows changes in global greenhouse gas emissions between version 5.4 and 5.3 in the same layout as the previous one. Here you'll see that we have a large decrease in fossil fuel and industrial carbon dioxide emissions in the reference scenario in version 5.4 compared to version 5.3. This is largely due to the updates in technology costs and deployment. Finally, this is total radiative forcing in the reference scenario on the left and in the 2.6 watts per meter squared scenario on the right. In this figure, version 5.3 is shown in green and version 5.4 is shown in orange. This concludes this presentation on GCAM version 5.4. For more information on GCAM is available at the links on this page. The first link is the link to GitHub where you can download GCAM. The second bullet shows the links to the documentation, including a complete list of updates. In this presentation, I have focused on changes that affect the main GCAM scenarios. However, we've also added some optional features that I did not discuss. These are listed in that link. Finally, there's additional information on GCAM on the JICRI website, and additional videos will be posted to the final link on this slide. Thank you.